I'm a main person with Cornerstone Systems, and we're going to talk a little bit this morning about automatic planning. What kind of problems do we have in planning that we have the need for automatic part planning? Flow down. That's a big problem. And what are we trying to flow down to the shop floor? We're trying to flow down specifications. How many of you guys have books like this at your office with lots of little sticky notes coming out of them, lots of highlighting, all that good stuff? You know, what happens if you lose the sticky note? Somebody comes and talks to the guy when he's going across the chart and he moves his finger and picks up the wrong number. The amount of information from a specification is large. You have the loading requirements, the thermocouples, the spacing, the time and temperature. It's really easy to miss something. Then you have your purchase order, the information that you're trying to flow down to the shop floor. Overrides of time, temperature, and other variables. What do you do with these? Do they end up being notes in the paperwork? Are they items that you write in and highlight? They need a place. Then you have customer flow down. This could be your specific customer. It also could be your customer's customer. Things like special packaging requirements. Their requirements are more stringent than the specification. What happens to these? Do they become sticky notes all over the planner's computer and desk and the order entry people? Does one person only handle a set amount of customers because they remember everything that has to go into the planning for that customer? Do you do multiple paperwork reviews? Are there binder books sitting on the desk with all those requirements in it that need to be looked at each and every time? Then we have the material, and it needs a voice too. The process requirements, the process times, and the temperatures. Other planning problems, inconsistent planning. Some shops have multiple planners, some only have one, but there always is probably a little variation depending on time of day, workload. This isn't necessarily saying the planners aren't doing a great job and that they're wrong. The paperwork is wrong or what they're doing is wrong, but it places a big burden on the rest of the shop. You're trying to train new planners. It's really hard to train somebody new when you got one person saying do it this way, one person saying do it that way, and another person saying do it that way. The shop floor, they do what they want because the paperwork's incomplete or it's inconsistent. They have 3 of the same jobs and the planning varies a little bit from job to job. Your quality people have a big job. When you have all that variation, you have all these different, whether you call them plans, process masters, however you term it at your shop, it's hard for them to maintain, to make sure that those are good, that the corrective actions get flowed down to the shop floor. And then you have your audits. Inconsistency makes it hard for audit prep. Which paperwork's right, which plan's right, which one do we want to use? Does it take us a long time to prep for an audit because we're trying to decide what we do, if the paperwork's correct, if it's going to come out correctly, and from that point. You have the problem, inconsistent planning also is part of this problem too, the planning not read or followed. A lot of people, you know, it doesn't matter how good your paperwork, you'll say that the shop floor doesn't read your paper, doesn't read the paperwork. A lot of times it's not read because it's incomplete, it's inconsistent, or it's a novel. It says, if it's this, if this, do this, if that, do that, if it's this customer, do this, for everybody else, do that. It takes them a long time to read and they don't have time for that. But also the Cliff Notes version doesn't help them out either because it doesn't provide them enough information. Then we have special circumstances. How are we flowing, if we have outside vendor requirements, how are we flowing down those requirements to our outside vendors? Corrective actions, how are we getting those in the system and flowing those down? Best effort basis, how are you protecting yourself when you have a customer that asks for a hardness outside of a range of the normal hardenability of the alloy? Do you have some way to identify these characteristics and how to proceed on a limited liability basis? Can you flag the orders, get approval from the customer so you don't have to buy the parts? The customer knows you're going to give your best effort to not damage their parts, but at least you have your butt covered for the rest of it. At this point I'm going to switch over and I'm going to show you how kind of the basic concept, or I'm going to plan a job for you in the software. The first time through, I'm just going to kind of run through We're going to hold all the questions till the end. That way everybody gets kind of a chance to take it all in. We're going to run one job all the way through. I'm not going to talk a whole lot. When I come back and I replan the job, we're going to talk a little bit more about what goes in here and where the information comes from and all that. So right here we have our simulated order entry. All the little drop downs come pre-filled and can be added to. At this point we have our auto plans, and I'm going to choose a 2759/1. The information I'm entering would be information that you would probably find on a PO. I just happen to have it written on this paper. And here again, as I said, all the we have information for primes, customers, all those are drop downs. They can be added to. Here where we have the auto plans, the concept with the auto plans is instead of having thousands, hundreds of part plans, process masters, you're going to have a handful of auto plans that cover probably 80% of the work that you do on a regular basis. And what this does for you is instead of quality having to, if you need a corrective action, something needs to be changed, you're only going to have to go change it on 4 or 5 plans. You know that the change is made and you know that nothing got missed because you're not going back and looking over lots and lots of process masters to make sure that that corrective action got flowed down. So I'm going to pick the one I picked again. On our order entry screen, the major important information we're looking for is the part type, the material, its received hardness, condition if that's in play, your section size. We have different kinds of part plans that can do different things, and that's a long discussion for this morning, so I'm going to leave that alone. We have our lot size, which I forgot to say from the last one. We have the ability to pick how we're going to put it in the oven, whether it's a batch, going in a basket, tooling. All these little drop downs are filled in like material. We have a very big material library, and those can be added to. Here we have our options and values, and these can be used in a variety of different ways. They can be used for packaging. If you do salt bath nitriding, you can put your media and your times in there, and they're just then a drop down that you pick and click and go. You have your surface hardness. There are also different units. If you don't need HRC, you can use any of these, and the system does the conversions for that. We have a few booleans here to the right that show things that you can add to the routing. On the bottom here, we have what we call stamps. And what these do is they will print usually a line of text, typically in the receiving inspection area, although they can be turned on to print in various ways through the paperwork. You know, the parts of the So then we have our entry screen, and what this screen is it has in it all the work that your shop would do, or all the processes that you would do for that auto plan. They're all allowed to be picked. And so I'm going to go, you can have these defaulted, so it comes up with your most common work if that's what you want. Typically a default due box is a receiving inspection, the packaging, and the final. I'm going to go ahead and pick my entries for this. We're going to wash the parts because we know they're dirty. We are going to load. We're going to do the austentize and quench. We're going to do the as quench hardness inspect. We're going to rack for load and temper to the required hardness. And at this point, I'm going to go ahead and run the job. And again, it's taking that time. Except for this time, we're getting a pop-up. The system needs some information. And what it wants to know is what the risk is for the part. And for this example, I'm going to tell them that the risk is high, that there's something about the part that makes it possibly difficult or to heat treat or damage the part. At this point, again, we have our stops, and we can have pictures. Pictures are real easy to add. All we have to do is do that. We'll have a picture on our paperwork, and I'm going to go ahead and print this so we can see what happened because of those choices that I made, and talk a little bit about those. This time, I have a new customer, I have a picture on my paperwork, and I have some new stuff. The handle with care stamp that I chose, that's now going to come onto the paperwork. It's going to be in blue. That high risk question that risk question that I answered that were high risk, that now gets me a different receiving inspection because of that, and that note that the parts are high risk. We've also chose to have the handle with care print in various locations throughout the paperwork, so everybody's aware that we need to be careful with them. And we did not make any changes to the time or the temperature, so all of our information that we had prior was what was complete. This example is the example in your paperwork showing the blue writing, the red, and all that information. Every material and auto plan in this system has a material file, and the material file is made up of a variety of things: material, process temp, temper, carburize, nitride, quenchants, all that kind of stuff. The one we're looking at here is for the temper. It tells us our process type, it tells us our HRC from and to that we're going for, it gives us our temperature, our plus or minus, and our specification, which everybody's going, that's great. But where did you get that information from? That information comes right out of the AMS 2759/1E spec. So there's no more having to look that up in the book, it's in the system for that. The system comes with the specification library, and it also comes with all the material information in it. And so the specifications themselves are handled a lot like this material file, and also the techniques and the process types. So that's just kind of some background. Now the risk, how did we get that enforced in there, and how did we know that that was going to happen? The system has the ability to have rules, and rules can be written on a multitude of different things. The rule we're looking at here is for the risk, and it says the name of the risk, and it says risk assessment for customer. The top half of the screen allows you to write rules on a lot of different things, and I'll come back to that in a minute. I changed my customer when I came through the demo the second time, and so I changed it to Scott's Machine and Manufacturing. So I'm going to write a rule. And what the rule says is, our typical rule says risk no. I don't want to know, I'm not going to ask, I don't care. What we're going to do for this customer is we're going to swap the regular risk no, and we're going to go to risk get, which then gets me that pop-up window with those selections, and each of those selections has a different thing that will print out on the paperwork. You can write rules on materials, type of materials, hardnesses, parts, part types, part sizes, and all that information. It's a very powerful tool. Another great use for the rules is shops have a lot of tribal knowledge walking around. There's people that have been there a long time, that know a lot of information. A lot of that can be developed into rules so that it's no longer just in one person's mind. It can be shared with the group and can train your next generation coming up. So a lot of the automatic part planning has solved some of our planning problems. We've taken care of a lot of our flow down. We have that information in the system. Any of those tables, the material spec can be tweaked to your specific requirements. We're going to get consistent planning. Our planning is going to look the same every time, no matter who plans it. We have complete, accurate, and readable paperwork. We aren't printing a novella, but it's in a nice format that the guys on the shop floor can readily see. So because we've taken care of those planning problems, we've gotten better, faster. We've improved our service because we can get the jobs out to the job floor. They're right more, our chances of being correct are higher. It lowers our cost on rework, and it reduces our fears for audits and liability to some of the parts. I'd like to thank you guys for all attending this morning. For additional information, I'll take a few questions here at the end. I'll also be at the Cornerstone booth today at 129 if you have any further questions. If you don't get a chance to get your question asked, my contact information is on the front, at the bottom left-hand corner of the front page of the handout.